You're listening to Within Tolerance, a podcast for machinists by machinists. I'm your host, Dylan Jackson of Protein Machining. This week, I'm joined by Uriel Eisen of Austere Manufacturing. Welcome.
Thanks for having me.
Yeah, I really appreciate you coming on the show. For anybody who missed it, you donated some buckles to the 100th episode giveaway, which was fantastic, and I really appreciate that. And I'm super
It's fun
excited
to be a
kind of
part
get
of
to
it.
pick your brains. Yeah.
For sure. Yeah, excited to be on here. Definitely listened to a bunch of other guests, so pretty excited to be on the show. Yeah.
Awesome. Well, so let's get into it. What is Austere Manufacturing? What do you make? Where can people find you?
Yeah, so Austere Manufacturing, we make high-end buckles for soft goods. So soft goods are like sewn products, typically backpacks, bike packing gear. You can find us at austere_manufacturing on Instagram, austeremanufacturing.com. And so basically, if you think about all the buckles on backpacks and camping gear, typically they're plastic, injection molded. Otherwise, they're typically stamped or die cast, like die cast zinc. And each of those things sort of have drawbacks. They also have big pluses, namely cost. So they're, typically pretty cheap. And that's great for a lot of applications, but sometimes you just want something that looks better, feels better, but also performs better. So that's kind of why we got into it. Been doing soft goods for many years, along with like machining and stuff like that. So finally just kind of got sick of the limited options and decided to try to do something about it. So,
well, that's a great segue into your backstory. So how did you get to where you are now? Both your experience in soft goods and manufacturing and machining, what
sure.
steered you to where you are now?
Yeah. So, I mean, just like pretty much every other guest, I grew up building things, always loved taking things apart and so on. So pretty typical story in that way, grew up, I guess I got lucky in that my dad is sort of a tool nut. So had a garage full of tools and I just kind of dove into that. So built cars, boats, like put skis on a bike, trebuchets, just whatever kind of came to mind, I'd try to build it. And actually growing up, so he was a wood guy. So I never really saw a mill or a lathe, but I was built a remote control car out of like a weed whacker we found on the street. And, all the classic, I guess, issues with precision and, try to drill a hole pattern to mount something and it's slightly off. Then you figure out what a center punch is and you're like, oh, okay. Still doing stuff on a drill press, but, and then the drill press was also my lathe. So I'd take like a grinder or something and just stick bits of metal in the drill press and, make quasi-turned parts. So, nothing too precise, but kind of try to make stuff work. And actually, it was only when I got to college, the first time I walked into a machine shop and just saw a mill and a lathe, and it was like $30 to join this club and you had access. And I was like, this is amazing. So, you had to go through a training, but automatically I'd already experienced so many of the problems that those tools solve that I don't know, it just all really made sense. And that was really exciting to jump on a machine where you could actually just, get a hole pattern the first try and not start sticking drill bits in and kind of cocking them to the side to try to make oval holes so you could get your bolts through. So that was kind of, I guess, my first introduction to machining. Really
What'd you
jumped
go to
into
college
that.
for?
Oh, I actually went to school in Pittsburgh, studied industrial design at Carnegie Mellon. And part of the reason I actually went to Carnegie Mellon was I wanted to, the thinking was this, in retrospect, I don't know if it was, correct, but I didn't really want to be sitting behind a computer, which is ironic because that's most of what I do now, with CAD and whatnot. But that was the thought. So I really wanted to build things. And so I didn't go for mechanical engineering, but I wanted to go to a school that also had mechanical engineering. So I'd be around those kind of projects and could kind of participate in that kind of stuff. So yeah, studied industrial design, but jumped into a bunch of projects in the Robotics Institute there. Ended up running the Robotics Club machine shop for a while. That was a club. So that was kind of, it's definitely panned out in that regard. I kind of joke that I'm not a good industrial designer because I have friends who are all doing like, classic industrial design stuff. It's like, I guess I probably could, but it's definitely not what's exciting to me. There's sort of different, I guess, schools of thought in industrial design. Some of them, I don't know if you're familiar with like RISD as a design school, but
Yeah, I am. Rhode Island School of Design, right?
yeah. So They're much more sort of process, like the process of making. So like understanding the process of making and having that sort of drive. This is my understanding. I didn't go there. So, if you've gone there, correct me, let me know. But so it's really understanding, how do you make things and what are materials and how do they feel and how do they act? And then letting that kind of drive how things are built. You kind of get away from that when you get into like, a lawnmower that has an injection molded housing or whatever, right? Like it's sort of arbitrary what that looks like. So you can really have fun with it or just, come up with something that kind of fits aesthetically, fits the brand. So I don't know, that stuff is less exciting to me than like digging into it, trying things, seeing what happens when you actually start to manufacture stuff and then sort of have that drive the design. So it's sort of like function first in a funny way, but then of course you end up getting back to the aesthetics and interactions. But anyway, so that was kind of my college experience. Did a lot of, as I mentioned, work in the Robotics Institute. That was a lot more interesting, I think, in the sort of on the manufacturing front, because they had a really nice machine shop and I could really just jump in. It was kind of awesome. They'd give you, a 3-hour training and I was like, have at it. So that was a lot of fun. Worked on a lunar lander project. Carnegie Mellon has participated in the Lunar X Prize. So they had an effort there and kind of jumped in. It's kind of funny. So I expected to go to college and, as I said, I kind of grew up doing woodwork. And so I figured I'd go there and then see how stuff is actually made. But it turns out, I don't know if you've seen this, but it just seems like everyone's kind of winging it often, especially in the prototyping phase. So
I think that like even in general, just in life, you kind of realize as you grow up, you're like,
yes.
Oh, nobody knows what they're doing.
Exactly.
And they're all just pretending. Okay.
Exactly. Yeah. So I was really expecting to go there and like everyone really knows what they're doing. And then it wasn't that. And I jumped into a project validating computer simulations of lunar landings in Earth's gravity, which is sort of a long way of saying like a 1/6 scaled model of the lunar lander that they're anticipating landing, and then just running the computer simulations and looking at the accelerations of the different feet and like how much energy is absorbed, and then just building a 1/6 scale model, and 1/6 just because of gravity like differences, and then looking at the results there and just sort of comparing them. And that was a pretty fun project. And I guess I was like able to actually contribute meaningfully because I was with a bunch of actually, they were mechanical engineer master's students, but they had never built anything. So it took a bit to kind of figure out how to communicate because I didn't really know what a Newton meter felt like. And they didn't really have any sense of like why you'd pick like aluminum or maybe welded steel or how to build anything. But we did eventually figure that out. And I'd just say like, okay, so if I were to jump on this, like how many, how much force is that relative to what we're experiencing? And then I'd go off into the shop and just like throw like a drop rig together to drop the lunar lander with different like from different heights and with different sort of lateral speeds and so on. And, it was about data collection. So turned out that getting sensors to put on those feet that had a fast enough refresh rate. I'm kind of in the weeds here, but
like I said, nerd out where
yeah. So
clearly it was a cool project.
It was very cool, especially, well, so we tried to put sensors on the feet to kind of give us the info we needed about like how the feet were hitting and how many G's they were experiencing. But it turned out that getting a fast enough refresh rate with a high enough like acceleration limit was just way outside of our budget. But I did a ton of dumpster diving while at college, and you find like the craziest stuff in the dumpsters, and I just go take them apart. I found what looked like a lathe bed at one point, and I was trying to like Google all the different serial numbers on it, and I finally figured out, it turns out that like as you add sugars to water, it changes. I'm not going to get this exactly right, but if you have polarized light and you shine it through water with different sugar concentrations, it will rotate the plane of polarization. And so this lathe was a way of measuring how far it was rotated. So it had like lenses on one end, and then I guess it went through a sample, there were parts missing. Anyway, all sorts of crazy stuff. Refrigerated vacuum centrifuges. So anyway, I was dragging.
What's funny about that lathe thing is that's what a bricks sensor does for your coolant. It's the exact same thing.
Oh, hilarious. Yeah.
Yeah.
So
So
this
that's
is
actually
so
what
it's
it's
a
measuring
handheld
is
one.
that polarization. Yeah.
Oh, interesting. That's very cool. That yeah, totally makes sense. So I mean, I guess so. It's not just sugars, right? I guess just generally additives in water affect that, and you can measure it.
Yeah. I'm still kind of vague on the how they convert sugar bricks into actual coolant concentration, but it's the
Hmm.
same functional sensor. When you're
Interesting.
looking at a bricks sensor,
Yeah. Well,
that's
I
what it
haven't
is.
tasted my coolant, but I don't think that.
I wouldn't recommend it either.
Yeah. So anyway, dragging some of my finds from the dumpster through one of the buildings, I found a motion capture lab, and I was like, "Hey, can we drop some lunar lander, like a model lunar lander, in here?" And they're like, "Yeah, no problem. Like that's fine." So we ended up doing it in there and getting all this data, and it looked like there were like the feet would hit the ground, and then we had all this noise, and then we got the data from the people who were running the computer simulations, and they had the noise too, and we're like, oh shit, that's pretty cool. So yeah, so that was how we ended up doing that. One funny thing, there were a bunch of interesting things there, and this was where being at a university was just so cool. So we wanted to figure out how to measure how much energy was absorbed at each foot. And if you take like aluminum honeycomb, you get buckling in each cell. And so it's a bit sporadic. And so the question was like, how many cells do you need before, on average, it's a very accurate measure of like displacement to like energy absorbed, if that makes sense. So anyway, so we ended up in the mechanical engineering lab, and they had one of those, what's it called, universal testing machines, like to do compression, and it would spit out a graph. So we had those in the different, on the four corners of the thing. And anyway, so that was that.
So during this whole time, were you into bikes and bicycles and all that
Oh,
stuff?
yeah. So in high school, my dad and brother were super into bikes, and they'd be like, "Hey, want to go for a ride?" And I was like, "No, why would I want to do that?" And so I wasn't that into bikes. I just rode a bike to like go to friends' houses and stuff. It was really just a practical thing. And then through college, first I was commuting on a bike, and then, then you're like, "Oh shit, I really don't like when it rains and I get all wet." So then I got fenders. Then it was like, oh, I wonder if I could carry stuff on the bike without having it on my back. Then I got into, rack and panniers, and the slow slide began. And, by the end of school, I think I had like 3 or 4 bikes, and I was full on. Yeah, really. That's kind of how I got into that. And interestingly, in Pittsburgh, they have amazing parks there, and there aren't a ton of people in the city. So there's like really good single track in the parks, like right in the city.
Oh, wow.
So actually, my girlfriend lived up on a hill, and I could get to class on single track. So that was a ton of fun. So that's how I got to class senior year. But yeah, so that kind of got into cars. Into bikes, not into cars. I like cars mechanically, but I don't love their impact on society. But that's a whole different spiel.
Yeah. So then how did you get from Pittsburgh? Because you're in the Pacific Northwest now. So were you always from there and then went to school out in Pittsburgh, or how did you get to where you are now?
Yeah, so I was out in Pittsburgh for school. I actually grew up outside of New York. And so I was in Pittsburgh, did a startup out of school in water filtration, actually. We did the whole startup thing, raised $1 million and did a bunch of pitch competitions and so on. And that's kind of how I got into, I'd say, prototyping, was through that process. And that was all in Pittsburgh. Ended up taking a job at Alpha Lab Gear, which is a hardware startup accelerator. So helping companies essentially like navigate prototyping with an eye toward manufacturability. So like, even if you're 3D printing now, at least understand what you're going to be looking at if you do injection mold this part. So you don't have to do a total redesign, and you don't have to like redesign the other parts of your machine, but you shouldn't be injection molding. You should definitely be 3D printing, but kind of just walking that line of like, do it fast, learn fast, but understand where you're going.
Oh, that's really cool.
Yeah, so that was a really fun gig. And then actually opened up a shop there, sort of doing that for different companies around Pittsburgh, and ended up getting a bunch of requests for, this is kind of how I got into CNCs. People would have me build one of something, and then they'd like it, and they say, can you make 10? We want to do user testing. And I was like, you don't really want to pay me to make 10 by hand. That doesn't make a ton of sense. Why don't you find someone with a CNC, and they'll be more precise too. Because I didn't have a machine shop, so I do like stuff with like a router table and templates. And then one job was like for smart homes. They needed some mounts for different things. And so it was all in Delrin. And so I'd make all these templates and then run different levels on the on the router table. And the router table I actually built in school because one of the professors said, so I came to school with a bunch of tools just because I was into tools. And then freshman year, they decided that they didn't like that like I was using all these tools for these projects, and it was freshman year. So they said we could only use tools that would fit on our desk. So I built a desk size router table. And so I was doing them on that thing, but it turned out that the whole top of it like dished by like 5,000. So I was trying to chase these tolerances, which isn't much for a router, but there was this, like 3M makes this Velcro that looks more like a bunch of mushroom heads. So it's not like hook and loop. So getting that to click together, like there's just not a ton of play to get it to click together, but still be kind of tight-ish. So I was like machining these seats where those got applied. And then anyway, I'm sure there's a better way to do it. But so when I ended up moving to New York because my girlfriend had moved to New York, and we were doing long distance, which was tons of fun. So I decided to move to New York. My family was there, and I figured I'd kind of get into CNCs in the process, just because it felt like I would take these jobs, do all this R&D, get people things they liked. They'd want 10 of something, they'd want 50, 100. And I was kind of handing that off to someone else. And it just felt like, I was leaving a lot of money on the table, I guess, having done the hard lift. And through school, I kind of like scoffed at, this is embarrassing in retrospect, but like CAD and 3D printing, I'd see all these people spending so much time in CAD, and I did some CAD in school, but mostly I just like draw something and then make by hand. I could do that a lot faster than people who were doing it all in CAD and then, 3D printing or whatever. And I also saw, I'm sure you've seen this where like people use 3D printers just in a really goofy way, like something that should be whatever, a weldment that would take whatever, 45 minutes or an hour to make. They'd 3D print, and then they'd have all these rigidity issues. And you're like, well, why are you 3D printing what is essentially like a folded piece of sheet metal?
Yeah. When it sounds like because of Alpha Lab and your past experience, you kind of know all the different processes and like when to apply them versus like, oh, I only know 3D printing, and when I've got a hammer, everything's a nail kind of thing.
Yeah, I think so. And this foreshadowing to some of the questions, but I'm definitely a process guy. I love learning about processes and like figuring out which one makes sense where. But yeah, so anyway, so I didn't really do CAD, and I just saw like the other really big thing about CAD, which I'm not telling anyone. I'm way behind the times. So whatever. Anyway, once you're done with the project, you are capturing every revision in a very accurate way. So while it's a total nuisance to do, especially at the beginning when you're way better in the shop than you are on the computer, so it's just frustrating because you're like, I could have built this, but instead I'm struggling to find the like right button to do the thing that I know how to do on a table saw. But the thing is, like, I'd build these prototypes for people of sometimes fairly complex things, and then there was another phase of the project which was like capturing all that information in drawing form or whatever, handing it off in some way, and that handoff process was no fun at all. Whereas if you've done something in CAD and revised it, even though it may be quicker to run something over to a belt sander and take a corner off because it's interfering with something else, if you just do that all in CAD, like by the end, when you have something working, you have perfect documentation essentially. And obviously there's a whole step, which is going through and adding tolerancing and all that stuff. But, it's a big leap compared to just having something that works fine, but is a one-off that someone built by hand from like shitty napkin sketches.
Yeah. Yeah, exactly.
Yeah. So anyway, that's what I decided. So I went to New York. I ended up taking a job at NYU, kind of building out a lab for their startup incubator. They wanted to get into hardware and wanted someone to build out a hardware sort of prototyping lab. So ended up doing that, and it was a great time to kind of dive into CNCs. They already had some CNC equipment. When I say CNCs, they had a laser cutter and a 3D printer, and they're like, "There, we have a prototyping." Yeah, exactly. And I was like, "Well, kind of dime a dozen. So yeah, brought in a bunch of tools there. And one of those was a CNC router from CNC Router Parts. Had fun kind of building that. Oh, also in college, and this is getting kind of long-winded, so I'll get to the point. But in college, I came across the question, or, I was thinking about precision and, how you end up with a precise machine without the first precise machine, right? Like, how do you have a square without having the first square? Those
Right.
kind of questions.
And they kind of
Yeah.
beginnings.
Yeah. So, that kind of led me to like fundamentals of mechanical accuracy, and then reading a bunch of books on precision and precision engineering and that kind of stuff. And anyway, so it was really fun to actually build a machine. They sell you a kit, so build a machine. You're putting it together, but still, it's kind of interesting to think about. How to build it, how to calibrate it, how to measure things. I don't know, and what those measurements are actually telling you in terms of the geometry. I feel like it's kind of easy to measure something and think it's telling you one thing, and then it turns out it's not. So that was a fun experience. Did that. And then my girlfriend and I are really into bike packing. We've done a bunch of trips. We've done a bunch in college. And then after college, went to Ecuador in the Ecuadorian Andes, did some bike packing there. Anyway, the East Coast, if you look, so there's a website called bikepacking.com. I don't know if you're into bike packing at all, but
I've never done it, but it looks fun. I mean,
I've
now had a few guests on here that like have done some form of it. And
excellent. Yeah. So bikepacking.com has a map of like bikepacking routes worldwide. But if you look at the US map, it's sort of like a gradient from east to west. So we were kind of like, we tried to plan these trips on the East Coast, and it's like either you're not allowed to bike, or you're not allowed to camp, or it's just like you're mostly on roads. And we're both more into like the off-road stuff. So we wanted better access to outdoors. So that's kind of what led us to look at this side of the country. And she's actually from the area, so we're in classic pandemic form. We're actually living in one of her parents' houses. We're renting it from them. So
I mean, it sounds like it worked out perfectly though.
yeah, it's great. I mean, especially for starting a business. So I also set out to buy a CNC in that move, and was looking at CNC router parts and ended up with a Speedio. So
yeah, so talk to me about that how you went from a CNC router parts router to a Speedio, because that's not quite a hop, skip, and a jump.
No. Yeah. So, I mean, as part of that same, I definitely at NYU definitely saw the advantages of I don't know, the advantages / I was pretty intrigued with the whole process of, CAD, CAM, CNC workflows, and what that made possible in terms of designing products. So, as I mentioned, I've done a bunch of prototyping and R&D for other companies, and typically I'd hand off a prototype, and then I watched them have all these issues through the manufacturing process. Because, as anyone who's done it knows, you always run into issues, and, depending who your suppliers are, they like this thing or they don't have that tool or whatever. So you end up solving all these problems or not solving them. And then like a project dies because no one who was familiar enough with kind of the real constraints of the product was working on the floor in the manufacturing plant, like live answering questions, and just saw like so many, what I felt like big opportunities to just kind of get those two things sort of better aligned in terms of the design and the manufacturing. Also, NYU at the end of that was when the pandemic started, and we ended up. Did you see the like 3D printed face shield stuff?
Yeah. Oh yeah.
Yeah. So I don't know if you printed any, but they took like 25 minutes to print one of the headbands, and then you still needed to laser cut like the face shield.
Yeah. By the time that I kind of got my 3D printer up and running, it was there was too many people doing too good of a job for me to try to half-ass it and limp it at the end there.
So anyway, so that was like right at the beginning, I saw those coming out, and I tried to print one, and I was like, this is insane. Like people need, like we were talking to hospitals, because NYU has a bunch of hospitals too. So we were talking to doctors, and they're like, yeah, we don't need 5. We need like 50,000, right?
Oh, geez.
Yeah, so it's kind of crazy. So I ended up, me and a couple other people sort of sat down and just redesigned the things to be fully done on a laser cutter or like a drag knife, like a vinyl cutter kind of deal, and got that process down, spit out a design, and somewhere between like 1.5 and 2.5 million of these things were made all over the world. We made 250,000 of them. We ended up like getting a bunch of die cutting shops. Like we'd find these like cardboard die cutting shops. We redesigned it for that. And then we're just like punching out just a whole bunch of them. So it was pretty interesting to see, and kind of just leveraging like actually knowing, being aware of different manufacturing processes. Again, like these cardboard guys weren't like, oh, I'm going to make face shields, right? They're sitting there being like, man, this pandemic's pretty crazy. I wonder what's going to happen. So we just went in and we're like, hey, you guys can make these. So got a bunch of plants kind of running on that. And why did I bring that up? Oh, so I was kind of thinking about like just manufacturing a product, I guess. Like actually I'd had all these ideas over the years, and I did a startup at one time. It wasn't really like I was sort of the product guy, but it was someone else's kind of vision around water filtration. My co-founder, she was really into international aid and getting people access to drinking water, and I was like, this is definitely something I can get behind. So I jumped on board, but it wasn't really a problem I'd experienced. So I had all these product concepts and thought it would be a good time, seeing as we weren't doing a ton of networking at the beginning of that thing. So I was like, all right, I'm just gonna like give it a shot. So I looked at like CNC router parts. They have their smaller machines. It's a gantry style, all extrusion. I mean, it's a CNC router, right? So you can cut aluminum on a CNC router. You can get nice surface finishes, so on and so forth. But the rigidity, I had gotten pretty tired of trying to design parts that didn't require tool changes. It's just like a goofy constraint to spend time on. So anyway, so I did the classic thing that me and I'm sure everyone else getting their first CNC, it's like, I looked at that, then I was like, okay, maybe I want a tool changer. So then I was looking at a Tormach, reading all the forums on Tormach, and then I was like, you know what, if I'm already looking at a Tormach, maybe a Haas, and then reading all the things about Haas's. And the other thing is like, I was going to stick it in a garage. So that's 4-inch slab and then not a ton of electricity.
So you're like a mini mill or something.
Yeah, exactly. And then I'm like looking at the mini mill, and then I forget how I came across the brother, but I guess, yeah. So anyway, I forget exactly how I came across it, probably on one of the forums, practical. Mm-hmm. And then it was just like, okay, I could get a mini mill or I could get a brother, and it just seemed like the brother was, quite robust in terms of like software and hardware. It was just a solid machine. And then the other thing is being in the area I'm in, dealing with Yamazin, and they're notoriously, very good to deal with.
Oh and yeah, I totally. That's one big reason we bought our S700, and we are actually hopefully Thursday getting our second Speedio. So I totally
saw that. That's pretty exciting.
Thanks. Yeah, I'm excited.
The F600 is a cool looking machine. I'm excited to hear about it.
I think it's like one of 3 in the country. So it'll be really interesting to kind of dive into the differences. The travels are very similar to our S700. We only lose a couple inches in X. So it'll be fairly close apples to apples between the S and the F.
Did they shave off a couple inches because it's like a similar footprint? And then it's just the traveling gantry, or do you know?
I have no idea. I know that the whole thing is about rigidity, so maybe limiting that travel on the gantry helps that. Sure. But or maybe they didn't want to make the bed bigger to accommodate that. I really, to be honest, I'm not sure at all. But yeah, it should be fun. It's, I think, almost a full 50% heavier than the S series is. So
wow,
that alone should be quite a bit more dampening and rigidity.
Yeah, for sure. So the CNC router I did end up building at NYU, I had picked up this big welding. It was an automation table. So it had like a 3/4 inch, or maybe it was a 1-inch top with like 1/4 20 threads machined in it, a big welded base that was like 1/2 inch steel in parts and 1/4 inch in other parts, all welded and then machined flat on the top. So it was a pretty beefy table. And so I ended up taking the legs off the CNC router and popping it on bolting it down to the table. And it was a huge improvement in rigidity. But then I did like some test helical cuts just to see if I could like hit the resonant frequency of kind of the table. And it was definitely bouncing around. And then it kind of hit me that like, they don't build VMCs out of like 2-inch plate for fun, right?
Right.
They're not like, I know. Yeah. So like that's what it takes to get that kind of rigidity. So no, I mean weight is there's no replacing it. But so I was kind of looking at like the brother sort of at the Haas, but I was kind of like not, I don't know. I like to buy things that I think are just going to keep working and I don't have to worry about. And I know a ton of people have great experiences with Haas, and I think like the value is really, really high with those machines. But reading about people like having issues with like chip evacuation and just like weird software bugs from updates, I don't know. I was just like, I don't really want to deal with that. So I was kind of looking at the Speedio and the Akuma Genos, but
That's a big machine.
Exactly. Yeah. So I was like, I don't really want to put that on a 4-inch slab. I don't necessarily have the power. So now I'm looking at like whatever, 10 or 15 grand to update the service to the building. That might be an overestimate, but that was just a guess. And the other piece was, I don't have a ton of experience on CNCs, and looking at the replacement cost of the spindles was a big motivation for me.
Oh yeah.
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 So
no
I
joke.
was seriously. I was like, okay, I'm going to buy, like, this is a huge investment, just a big chunk of change relative to the other tools I have. And then I was imagining kind of getting started and then like crashing a Genos, and it would be like, I could either buy like a used Camry or a spindle. Now, granted, you can buy a used Camry for $6,000 too. So maybe that's unfair. But anyway, $6,000 somehow felt very different than 15 grand in terms of.
It for sure is. So what steered you towards the 1,000? Because I mean, your current product line could easily fit on like an S300.
Yeah, seriously. Yeah. So interestingly enough, I mean, I didn't really have a good sense of what I was going to do with it, which is kind of odd. I had a list of products over the years. I just keep these lists of products under different processes for different tools. And so I was kind of like scrolling through my concepts for like CNCs, and they're pretty wide ranging. And the other thing is I still do prototype development for other companies, and looking at the footprint of the 700 versus the 1000, they're pretty similar. It's like 8 inches and 6 inches or 8 inches and 8 inches. I forget exactly, but it's not a lot. And I was just imagining like, being able to easily put holes in like a weldment with fairly good positional accuracy, like exceeding the size of a 700. Anyway, I don't know. That was the thinking. Is like, okay, I'm spending X amount of money on a 700, and it's just whatever it is, like 10 grand more for the 1,000. So I went for the I don't know. It's still like at this point, I still don't know if it's the best idea. It is a lot heavier. I think it's like 9,800 pounds instead of like 75 or something like that. So like just puts it out of range of like a hand truck, although I'm sure you can, not a hand truck, a pallet jack, although I'm sure you can still move it. Yeah, so that's kind of why. Just like the table size was just hard to, I was like, I'm going to be kicking myself if I would need to machine like a big part and I don't have the room for it. And now actually with the automation I'm looking at, that table space is going to be pretty handy for kind of phase one of that, just in terms of laying out a grid of blanks on the table. So
yeah, that totally makes sense.
I don't know. Yeah, it was just, I don't know if it's the right decision. Recently I was looking at just standing in front of a 700 again, like at Devin's shop, like in manufacturing. And it is a lot smaller, like 8 inches by 8 inches is not nothing. I have the thing like shoehorned into a little barn. So there is not a lot of room around them, but no, I'm loving the machine.
It seems like it's working for you though. Yeah. I mean, it's all working.
It's all working.
So,
yeah.
You had the Speedio. How did you, were the buckles already on your list, or was this something that just popped up, one night you were getting real sick of your buckles breaking?
Yeah. So I had been designing buckles for years. So I started sewing. I couldn't find a backpack I liked, sort of the classic make your own gear story. Couldn't find a backpack I liked, or really any story of people who build things. And so I decided I'd make my own backpack, and then spent 3 years figuring out how to do that properly.
So was this like,
Yeah, so it was before that. The Convoy was, I would say, one of the first, and that's a project for those of you listening, just like a project on my website. I think it's Eisen.com. A bag set I designed. That was, I think, senior year of school. So I got into it sophomore year, I guess. And I went home and first broke my mom's tabletop sewing machine trying to put way too many layers of canvas through it. Got a like Chinese knockoff Juki. Juki's like a pretty good brand of sewing machines. It's like a knockoff Juki, and then made like, I don't know, 50 some odd hats over winter break. And I started with hats. So, I mean, this is gets back to the buckles. I started with hats because they're small, but they're difficult to make well because they're so small. If you get the panels misaligned, they look really bad very easily. So they're not very forgiving and they're small. So I figured I wouldn't waste a lot of fabric and I would get good at patterning, which in my opinion, like if you're sewing, the pattern making is the real challenge. The sewing is like, yes, you need to get good at sewing, but it's pretty straightforward. So similarly with the buckles, I had been designing, so I started with those, and every project I did with soft goods, I was pretty frustrated with the available buckles. I don't know if you're familiar with Cobra buckles.
I know you had mentioned them on your website, and I think I've seen them on your Instagram too, because you were talking about, how they're a little overbuilt for what you need.
Exactly. So, I mean, it's an example. I bought some, years ago because it was the only buckle I could find that looked and felt really nice. That said, they're meant for fall protection or skydiving or whatever. So it's a little, I don't know what you're doing with your backpack, but you don't really need that. And you pay for it in weight. So they're quite heavy. So anyway, I'd bought those, and every project I'd kind of look through the catalogs of available hardware and end up kind of settling for what I could find and just kind of making it work. And then I ended up doing a project working on spacesuits. Actually, while I was in Brooklyn, there's a spacesuit company in Brooklyn, turns out. And I ended up doing a project for them for NASA. And while I was there, unsurprisingly, they make all their own hardware, right? Like, they have really high loads. They have very tight constraints on materials permitted by NASA. And, you're inside the suits are pure oxygen. So like there's all sorts of limitations in terms of like, you don't want things catching on fire, producing static. Obviously,
no
sharp
sparking.
Corners aren't it. You can't have it. Yeah, all that stuff. So very tight constraints. And then weight is a huge deal when you're firing things into space. So they make all their own buckles. And I was just seeing like what freedom that gave them in terms of their design abilities, right? They weren't changing their design of the spacesuit to make some buckle that they could get off the shelf work. They would just go like, okay, we need a buckle that's for this width and this thickness webbing, and it needs to hold this many pounds and so on and so forth. So after seeing that, I'd been designing my own buckles sort of out of frustration. I was like, I wish this exists and I wish this buckle existed. So I had kind of like a lot of sketchbooks with drawings of different buckle concepts, and seeing that.
You've got some pictures on your website of them.
Oh yeah? Cool.
Yeah, the sketches,
Nice.
yeah.
Oh, cool. I'm sorry, I haven't been on my website in a bit. Yeah. So anyway, I kind of so the CNC arrived and I was like, all right, I have all these ideas. Why don't I start with buckles because they're very small. So I'll learn about CNCing in a real, on a real machine. Not that the others aren't real, but on this machine, just kind of quickly without burning through a ton of materials. And then the other piece was, I really wanted them to exist. So I make a bunch of bike packing gear. And like this buckle is the thing I was missing for bike packing, because I don't know, for all people who bike pack, the rear, you put a seat, like you put a bag kind of tied to the bottom of your saddle, and it over time, like as you go over bumps and stuff, it loosens and rubs on your wheel, and everyone just kind of accepts that and then ends up like stopping on downhill on like single track descents and stuff to cinch it back up. And that's just a failure of the buckles, right? They're not designed for like the jostling, and so every time you get a little bit of slack in the webbing, it works its way back through the buckle, so it gets loose. And so the buckle that I'm making right now, the cam buckle, I do 2 of them, but those cam buckles, if you've ever tied a kayak to a roof rack, it's the same it's the same concept, right? It's not a new design by any means, but if you look at those die cast ones, they're like 45 to 65 grams, which is a lot to add to, biking. Everything's about weight. So that's the buckle that I was missing. So I just decided to start there for selfish reasons. And then I figured it was a good place to start because it was small. So I wouldn't waste a lot of materials, but it had multiple components. So I would have to figure out all the challenges and design considerations of an assembly that needed to work well together and all that. So that's kind of how I landed on that project to start.
Okay. And then, so you talked about being big on processes. What is your process? Because I really, and I guess let's start with what your process has been, and then we can go into the questions because there's quite a few questions about what you've got upcoming. But how did you start? Why did you decide on, the laying and all that stuff?
Yeah. So let's see. I started off with a different vice that shall go unnamed. I didn't love it. I had all sorts of issues with like jaw lift and all sorts of other stuff, but that was my prototyping. So I just figured prototyping, I just I hated flipping parts when I was working on the CNC router. So I got a fourth right off the bat and then put a dovetail vice on, or a dovetail fixture on it. And that was my prototyping process at the beginning was, pop something in the vice, 3-axis vice, machine, do a dovetail op on it, and then put it on the 4th axis. And that lasted for a bit. It kind of worked, but what I quickly figured out was that, I could make good buckles on it, but the real challenge with this business in general is it needs to be really efficient. Like how those buckles are made can't take a ton of time. So prototyping so far away from the eventual production method was not really like cracking the nut that needed to be cracked, if that makes sense. So I was just, I could make a buckle and then I'd be like, great, this is a good buckle. And then there was another big phase of the project, which is like, okay, how am I going to make these with, quick enough cycle time where I can actually sell them?
So that kind of gets into Obsidian Tools' question, which was, why did you go small tombstones on the 4th instead of a big tombstone, which you keep in the machine with, ZPS plates, some kind of 0-point system that you just swap out individual sides of the bigger tombstone?
Yeah. So I mean, this is something I looked at, kind of that option of doing a big tombstone. I looked at doing more of like a trunnion with pallets. And then I also looked at the small tombstone. So to start off with, I mean, you asked about Lang. I was kind of looking at Lang versus Rocklock. I knew I wanted to be able to load stuff offline while the machine was running. I guess the Rocklock system is cheaper, but the studs are about twice the price. And once you start down one road, you're really locked in there. And so actually, talking to Cobra Frame Building, he kind of tipped me off. He was like, yeah, the studs are really what end up costing a lot. So I went Lang for that reason. Like a set of 4 studs, I think is like $76 for the 96 millimeter plate, which are 20 millimeter studs. And then the smaller plate, I think they're like, $65, right? Versus like, I want to say like 100. I haven't bought them, 120, 140, something in there.
There's something like that. Yeah. We bought a bunch of the vice adapters from 5th Axis and master pallets at my day job. We got like a ton of laying on all of our machines, but the 5th Axis stuff was just cheaper for those.
I have the calibration plate from them for that reason.
Right, exactly. Because I think Lang wants $1,500 or $1,600 for the calibration plate.
Like, right.
But I sent Joe a bunch of the studs because I was like, we're not going to use them. I need to get rid of them so that nobody mistakes them and puts them in the wrong fixture and, break something. Right. And so I was like, who do I know? I think I said something to him and a few, I spread them out through the machinist community of people I knew.
That's a nice gift. Yeah. So that's why I ended up with Lang. And then in terms of the small tombstones, I guess it's interesting. I don't feel like the cost of fixturing is talked about a tremendous amount, but it's obviously really expensive, right? Like building a big fixture of some kind, it just really adds up quick, So you have the aluminum just to make the thing, and then you have all these little fixturing bits of metal that are always tempting to make yourself. And then you're like, I think there's better uses for my time. So, one of those, like, I forget if it's like Piranha Bite or what's the other one? Anyway, the little like serrated, hardened steel jaws that you can screw into your aluminum fixtures.
Yeah,
Those are
I'm
like
totally.
$25 a pop. And that's not a lot compared to the machine and compared to everything else, but it really adds up. And then I was talking to Greg from Luma Labs, and he was kind of talking about something that I'd sort of started seeing in the small tombstones, which was, one pocket or two pockets starting to misbehave. And now you're running like a eight. I really wanted single piece flow on most of it. And obviously it's not single piece, it's 8-piece flow. But kind of just thinking about that, and like one of them wears out, and then you go like, okay, do I reprogram it in like CAD, like shift the CAD model and do my cam that way? Or do I machine a new one? And like inevitably that just burns a bunch of hours to make a new fixture? Or like, how do you actually keep really good parts coming off of your fixtures every time? And some of this I'm sure is due to my inexperience, but it's just, that's kind of what I was thinking about. And so the small tombstones give pretty good access to op 1 and op 2, and then they're pretty inexpensive to make because I went to the smaller stud, the 54 millimeter Lang plate, and so it was like coming out of 3¼ inch square bar. So the whole bar was a lot cheaper than the 5.5 inches or 5 inches you need for the 96 millimeter plate. So that's kind of how I ended up going pretty small. Was I was just like, let me just, because I have a bunch of different buckles I want to make, a bunch of different fixtures I want to make. So it was somewhat price motivated, and then just like keeping the weight down for the operator to switch them out was something I was kind of thinking about. Yeah, I don't know. I don't know that it's the right answer, but as I'm moving away from it, so
Right.
I guess it
right.
wasn't the right answer.
Well, it's worked though up until now. It seems like you've been selling a bunch of buckles, so it's made your
Yeah.
business, at the beginning. That's great.
Yeah, got us off the ground. I mean, the limitations for sure, which I think some of these questions allude to. I don't have very good, very long run time on them. So I have like 15 to 20 minutes, which you really don't get a lot done in 15. It's just, it's hard to do a lot of other things in
Right.
that cycle time. So
They should have bought a slower machine.
yeah, absolutely. Maybe that Tormach would have been better.
Well, so speaking of processes, then you've showed a few pictures of this automated gripper system. Molly No asked, about the air system for the claws, and Cobra Frame Building Joe asked, what are the goals for automating with the gripper? So why don't we go into what's the future for austere, and where are you going with all this?
Awesome. Yeah. So as I mentioned, the short cycle times were pretty frustrating. So I was looking at either doing a large tombstone or a trunnion with a big pallet, and all the things I kind of mentioned just really made me hesitate. And then I made a big pros cons list with like costs of the different options and what they gave me and what the drawbacks were. And the trunnion was going to be pretty expensive to implement, like just off the bat. It was going to be like, I don't remember exactly, but say $8,000 with all the fixturing and stuff. And the gripper system. So anyway, Peter from Yamazin, I think he's Pacific Brother on Instagram.
Oh, okay. I didn't know who was behind that Instagram.
I think that's right. Now maybe I'm wrong, but
I've heard Peter's name a bunch of times.
Yeah, so he came by the shop and was kind of like, hey, for your small parts, like you might look at these grippers. So, at the beginning I looked at it and I was kind of hesitant to jump into automation. I mean, obviously it's pretty exciting in terms of the possibilities, but there's a lot of implementation questions that I was a little unsure of. And I mean, as anyone who's gotten into this kind of stuff knows, like the cost of the parts, what the first, the big items, like you buy a CNC for whatever, a bunch of money, and then there's all the tooling, right? And those incidentals, not incidentals, like they're necessary to the process, but they really add up fast and represent a pretty substantial chunk. So I kind of looked at all the options and weighed them out, and the gripper system wasn't much more than the trunnion, And the big thing that the gripper, I think, is going to give me is we have a bit of so our first plan is just to put kind of like trays on a 0-point system off to the right on the table. And then we have our fourth axis that it's going to load off to the left. Hopefully that's going to be, the gripper will pick up a blank, put it into the pneumatic vise, machine op 1. We have a strategy for flipping it to op 2 with just the gripper. We'll see if that pans out. And I don't know that we're going to start with that. We might just do, op 1, then it puts it back in the tray. The gripper gets it out of the vise, puts it back in the tray, and then we manually flip. So the tray would have, say, like 10 blanks for op 1 and then 10 that we've manually flipped into pockets for op 2. So that's another option just for phase 1 of the project. And so that's where we're headed with that. And then the eventual goal is to have a pneumatic gantry style loader. So we're going to remove the left panel of the machine. This is going to take months, many months to get there, but because we have a lot of other stuff happening in the meantime. But the idea is to load blanks in that panel and then just have a little vacuum cup on the end of a pneumatic actuator that comes down, picks one up off the top of the pile, scoots over 12 inches and puts it down into op 1 on the fourth axis.
Okay, so you're planning on moving the gripper kind of thing offline, so not using the spindle.
And then the gripper would come in to flip it from op 1 to op 2. So the limitation with the gripper, not the limitation, but the thing about the gripper is designing those jaws to both pick up a blank, but then also have the right geometry to flip the part from op 1 to op 2. That's the trick. And I think it will be possible with some parts and then sort of difficult with other parts, if that makes any sense.
Definitely.
Yeah, so that's kind of the thought. So the thought would be if we can handle op 1 with a different mechanism, then our gripper in the tool changer can have jaws that are really just specifically designed to get in there and flip the part from op 1 to op 2. And then it would come and eject the part from the machine so we can inspect it and then, make sure we don't make a bunch of garbage. So that's the goal. But in the meantime, and honestly, like, I don't know when we'll get there exactly, but in the meantime, what it really gives us is we will be designing essentially soft jaws, right? Like that's it. Like those tombstones took us, I don't know, you could spend a few days designing it, making sure you have all the tool access you need, and then you have to fab it and whatever. So it just takes some time to make a new tombstone. And because of that, it's a pretty big lift to get a new buckle style to market. And for making buckles, not only are there different style buckles, like there's a side release, the classic clip that actually separates like on a sternum strap on a backpack kind of deal. There's that, there's ladder locks, tri-glides, loops, D-rings, all this stuff that people use frequently. But then there's also 1/2-inch webbing, 9/16, 3/4, 1 inch, 1.5 inch, 1 3/4, 2 inch, right? 2.5 inch. You see what happens pretty quick is you have like a million SKUs, and hopefully not a million, but a whole bunch of SKUs, and designing fixturing for every single one really has been a big lift. And so the thinking is, and we'll see if this pans out, but the thinking is basically we cut down the amount of effort required to launch a new product and are really trying to optimize all the processes to be high mix, low quantities. And that's across the board through coding. That's everything, because it will allow us to do some interesting things in terms of working with manufacturers of soft goods to actually deliver buckles that are specifically tailored to their application, rather than just like, okay, we can get the cost way down if we just make millions of these things, which is what exists right now. So that's the thinking, is that it'll just let us do that a lot faster and easier.
That makes sense. So another one of Joe's questions was, what are the biggest challenges with producing such an excellent product for such a low price?
Well, it's a very flattering question, firstly. Thank you. Thanks, Joe.
I was really impressed by his, doing pull-ups with your buckle just around a pull-up bar. That's like, I had no idea where the strength was on the end of your buckles, but seeing that, I was like, oh man, I can do about anything with these.
So, it's not load rated, so don't use it for safety critical things, but we do a lot of pull testing to failure to make sure we're happy with the results. And with this, the webbing tends to break first. So, and that's at a lot of pounds. So, it'd be nice to get a rating on it, but that's, not there yet. Anyway, yeah. So I guess the challenge is, I mean, he sort of asked in the question, right? It's doing this at such a low price. So the challenge is this: a plastic piece of hardware costs between 5 and 35 cents. Right. So you have a team of designers spending a while making a really nice bag, and then you buy really nice fabrics, and then it's all held together with those pieces of plastic. So while I don't think that makes a ton of sense for every application, like especially when you get into gear that people are really pushing the limits with, but it is what people are used to, right? So all these bag manufacturers that we're selling to, that's what they're used to. And that's the challenge. So we're trying to launch something that is a lot more money, right? Just in terms of orders of magnitude more than they're used to paying for the same thing. That said, it's not the same thing. So that's the challenge. I mean, that's been the challenge. So that said, I was frustrated with the available hardware. It turns out that that's not just me, right? Everyone who's doing soft goods is kind of a little bit yeah, we use this because that's what's available, but we don't like it. And so there's a lot of products that I think are not going to bear the cost of this hardware. But I think there's also a lot of applications where, bike packing, or, you're out, you work most of the time, and then you take a week off to go do some big bike trip, and you don't want to be dealing with malfunctioning gear. So I think, and the other thing is just I think it looks nicer, it feels nicer, I like using it. So I think it's going to happen, but that's the big challenge. It's just cost.
I totally agree though. I've got some really nice motorcycle pannier bags, soft bags.
Yeah.
And they've got cheap buckles on them. I mean, they've got some of the metal D-ring stuff, but they also have cheap plastic buckles. And I would much rather have spent a little more money to have something nice like your buckle than, spent when I did and have these cheap plastic buckles that I'm sure will sun fade eventually.
Yeah. Yeah. I mean, that's my feeling. And again, not for everyone, but I really do feel there's some applications where it's just yes, percentage wise, it's a big multiple, but in actual dollar amounts, it's not a huge amount more that you'd spend to just have something that, you can count on. So anyway, yeah, so that's the big thing. But again, we've really, that's not been our bottleneck. Our bottleneck is internal, doing everything basically in-house while trying to launch other designs. And then also we've been doing a lot of moving, which takes a ton of time, not of the shop, but of our house. So that's been, just slowing everything down.
Right. So Devin also asked, when are you going to stop playing with processes and start making some parts?
When I die. I don't know. Yeah, I'm not, I don't love standing in front of the machine. That's not the part of this I enjoy. So I do it. And, I think to a fault, I'm this way. When I was getting into soft goods, someone mentioned that in production, no one uses pins. So I just never used pins because I was all right, well, I want the fastest way of making product. And also I want to be simulating how they're going to be doing it on the factory floor so that my patterns actually translate well. The result was you see these people who just start sewing and they make really nice bags right off the bat. That's because when you use pins, you pin it, and then if it's weird, you just repin it until it looks okay. And that's a bit of an exaggeration, but so I kind of beat my head against that for I don't know, 2 or 3 years before my patterns were good enough that when you sat down on a sewing machine, they actually went together and looked good coming off of the machine. So I don't know, I'm definitely really interested in thinking through how all this stuff happens. And, Devin's 10 minutes away from here. So I always call him for help because he's been doing this a lot longer than me. And so I think he's probably responding to the fact that I'm constantly redesigning my processes to make them a little better. But, there's sometimes no replacement for just banging out a whole bunch of parts you can sell. So I don't know. We'll see.
So before I get to our last question, how do you balance that? Because you're trying to, implement this gripper. Do you block off time during the day that you're working on that and then you go back to production, or, how do you balance that kind of change?
Yeah, it's a little tough. I mean, there's some limitations in terms of the biggest issues I think I'm running up against is like I can't change the setup. Like I don't want to touch the fourth axis because all of my tombstones have been machined in position, right? And yes, theoretically, if I was really good at making fixtures, you could move them across machines, but I just know it's going to introduce some inaccuracy and I don't really want to have to deal with that. So that's the bigger thing in terms of managing just production versus this other stuff. You know, this first product, as I kind of mentioned, it's very niche, bike packing gear, but then it's some small percent of bike packing gear of people who really want, nicer buckles and who have experienced the drawbacks of some of the other stuff available. So we actually recently implemented Kanban cards across a lot of that. So that makes that a lot easier.
Oh, cool.
Like I just don't really need to be thinking about, are we low on this? Are we low on that? Like it all kind of triggers in terms of production. And then in terms of growing the business, like it's very clear to me that the best use of my time is designing new products, is designing other buckle styles that people have been asking for. And so even the gripper stuff is a big kind of time sink that is not that, but I really am hoping, and stay tuned, we'll see how it goes. But the theory is that once that system is working, the nice thing about it is in prototyping, I will be prototyping on the same tooling that will be running production, right? So like I will cut a set of soft jaws that hold op1 and op2 on the pneumatic vise. I will load those by hand as I prototype. And then the only thing I need to do to move from prototyping to actual production is make a grid that will hold that size stock. But, I've standardized a lot of the stock. So I'll try to not, hopefully I already have a grid that will hold that stock, and then program the gripper to go pick something up and move it over. And Yamazon sent over some of the programs they've used for these grippers. And that was the big thing for me deciding whether to go this route. I read through them and they're just like really simple in terms of, it's like, I don't know, 20 lines. That's like, you put in the 00 of the first pocket that's holding a block of aluminum in my case. And then you tell it like, how many in X, how many pockets in X and how many in Y, and their spacing. And then it pretty much knows where to go. And so there's a master program that's calling a sub program for, load the vise or unload the vise or go get a new block or return a block. And so that's something I'm kind of thinking through now is like a lot of their programs are optimized for, set up a part and let it run for a month, which is I think where most people are implementing the gripper. But I think I want to pass more parameters between those programs so that there's just one master program per part. And then I don't need to go hand edit the rest of those programs for like, grid spacing and the XYZ position of the vise and that kind of stuff. So,
Yeah. Yeah. I mean, that should be fairly easy. And like, you could always pull that stuff from macro variables as well.
yeah. So I need to dig into that. I've yet to use the macro variables. So got to get the book and give it a read. But I think it seems not too challenging. So
No, it's all basic math and, basic passing stuff. You'll get it, no problem. You had mentioned new products, and our last question was from DFM Toolworks, and he said, what is your next product?
Yeah, so we have quite a few in the works, kind of debating between. So if you're familiar with the product, it's right now we have just a cam buckle essentially. So that's like an adjuster for webbing. So imagine if instead of a loop on the back of that cam buckle, it was what's called a G hook. So it's basically a hook that would hook into an existing loop of webbing. So that does two things. One, a number of companies of bag makers have asked about that specifically. So because they use G hooks right now, which allows you to disconnect that piece of webbing to get it out of the way and then hook it on. So it's sort of like a quick release, but the cam action means it's not going to slip as you kind of shake it. The other thing that will allow us to do is people who don't have a sewing machine and have a product that has plastic buckles, you can now take a set of like, wire cutters or whatever and just cut the plastic buckles out of a bag. And then this would hook into that existing loop. So it would allow people to retrofit these buckles onto existing gear without the need for sewing. So that's one we're working on. And then, just a whole bunch of others, but you'll see them on the Instagram as they get there, but it'll probably be a bit.
Awesome. Very cool. So you've kind of gone over some new shop things, but takes us into shop news and new things. What else is going on?
Let's see. So yeah, I mean, most of the stuff is just around getting this gripper implemented. There's a whole bunch of pneumatics that kind of needed to get hooked up and figured out. I don't know if you've bought pneumatic valves, but there are a million flavors. So like I was buying some SMC stuff and it's like a 20 character part number. And then every 1 or 2 characters is a variant, right? So it's like, do you want, this kind of electrical connector? Do you not, or do you want this kind? Do you want it to come with the connector or without? Do you want this port or that port? Do you want it center exhausting or, on and on and on. And for someone who, I don't know, I know I've used pneumatic valves in the past, but, just that many different variations, it was pretty tough to narrow down on exactly what would make sense. I ended up just, calling tech support, and because even beyond just what style valves you need with what size connectors and so on, there's also many different like product lines that offer the same valve, essentially the same valve functionality. But do you want that to be a manifold or a standalone valve? So figuring that stuff out really has, I puzzled through it for like a day and then I ended up calling someone. But getting all that stuff hooked up, that's the main thing. Machining a sort of knuckle to hold the pneumatic vise onto the 4th axis. Looking at possibly using a rotary union. I think at the beginning we're just going to hook it up with like a bit of slack in the hoses and then go through and make sure that the program doesn't spin the 4th axis too many times, and then either unwind it or just hand edit the code to go the other way, so it doesn't loop. I did see in the post-processor kind of documentation from Fusion, from Autodesk, there is some section on limiting, an A-axis. So I was thinking about maybe looking at that, but it's a little daunting always.
Yeah, I think you can not only limit it, but you can choose which way it prioritizes, like whether you want it positive or negative biased, I guess.
Interesting. Yeah, so I kind of need to dig into that possibly. But I think at the beginning, I'm just going to watch the program, which I'll do anyway. And then if it starts to go too far, I'll just find that line and make it go the other way, which is a bit of a workaround. But yeah, so what else is new? I mean, that's the main focus, really. Oh, yeah, so getting into winter here, it's going to start raining. Right now, I converted an electric smoker from Home Depot. That's where we do our Cerakote in.
Really?
Added a blower to it basically to circulate to get good heat distribution. But it was just a quick and fairly cheap way of having a large oven. Right now we move that outside to run it because it kind of off-gasses stinky stuff. And so as winter comes, you're going to need to move that inside and have some sort of ventilation, to pull air from around it and move it outside. So we'll be getting into that. Nothing else too exciting. Definitely, I picked up what's it called? Toyota production method or system or whatever it's called. And kind of gave that a read. Ended up like reading it 3 times in a row. Really interesting stuff to puzzle through and figure out, like single piece flow is the ideal, but then what are your minimum order quantities and all that stuff. So figuring all that stuff out, implementing Kanban more fully and, QR codes to reorder. You probably know this, but you can put an email right into a QR code. So you scan it and it will pull up on your phone a pre-populated email. So like a request for a quote or whatever. So doing kind of those things. And it just makes it so much nicer to be in the shop. And it just feels like at the end of the day, I've spent more time on on things that matter, because those things can really just suck up a ton of time. Devin's point, implementing that can also take a lot of time. So it's hard to kind of balance. And I don't know that, it's interesting to think about for sure.
Well, very cool.
All the lean stuff. Yeah.
Well, that kind of brings us to the last question I ask every guest, which is, what did you research this week? What have you, besides, I guess, pneumatic grippers, has there been anything else that you've been researching?
Let's see. So more broadly, I guess, like process reliability. So just thinking about like probing and measuring parts as they come off. Like, do you do every 1 or every 10th? Like, the real goal is to run this thing overnight. So I've been researching that and just trying to find more videos of like real world what people do. Like, it's really easy to find, those promo videos of like, look how amazing our system is. But I feel like sometimes those like gloss over the stuff that I actually really want to know, which is like, in reality, like how, I don't know. I was at a shop that was stamping, they make helicopters. And they were stamping helicopter seats, like the sheet metal pan that the seat goes on. And they just had a bunch of duct tape up in the stamping die to get the, and like it was to keep it from rippling as it slid in. So it was like, that's the kind of stuff, once you see it, you're like, oh, okay, like I can just do that if there's an issue, right? Like you never know which parts you can which corners you can cut. What else have I been researching? That's been the biggest thing, is like process reliability and which corners, where I should really be focused. Like tool breakage seems like a big one.
Tool breakage detection has been like such a piece of my, like I do prototypes, and even then I still use it on runs of 5 or 10, because it means that I can go start programming the next part or something and not have to worry about anything blowing up all my tools in my carousel.
And so do you run it after every tool?
Any tool I think might break. So
interesting.
Most roughing tools, in aluminum, if I'm only running like one part, I'm not going to run it. But let's say I'm running 5 parts, I'll put it after the roughing tool. I'll put it after any small tool, a 16th or smaller that might have follow-up rest machining behind it.
Yeah.
Definitely a drill, sometimes a tap if I'm going in afterwards to reach out for the hole or something. Just anything that can, if there is a way that breaking that tool can break another tool downstream, I check it.
Yeah, so I gotta get on that. There's just so many things that are on my list. So I end up like putting off these like super basic things for
tell you,
long time.
Since you're another Speedio owner, it's super easy. Just M98 P5000 after I'm assuming you either have a Blum or a Metrol tool setter. Yeah. So it's just M98 P5000 after any tool. But what you have to do is you have to make sure to never trigger it before a tool. So like, don't put it at the beginning of your program or you will blow that tool setter up. There has to be,
because it doesn't have the height offset.
Exactly. Yeah. So it'll try to drive the spindle nose to your tool setter.
I feel like someone posted a photo of that on the Slack.
I want to say Greg has at some point.
Maybe it was Greg. Yeah.
But it's happened to a few people, and it's scary. I've actually been screwing around with the tool breakage detection at work because we've got a few Speedios, and I think I have a way to actively check for a 0 offset and then error out. But I've still been kind of testing it before I try to give it to anybody.
Makes sense. Interesting. So you just need to make sure there's a height offset already registered.
Yeah. So if you're using Fusion after the M5 at the end of any tool, you can just type it in there manually or get your post edited so that it automatically puts it in there.
Interesting. Cool. Well, thanks for that.
Yeah.
I'll have to get on that.
I don't want to see anybody blow up their tool setters, but it is so dead simple. The other thing I did is I went into Program 5000 and I decreased the feed into the tool setter itself to like 50 because it was at 150 and that just seemed excessive. Like it's already a 5-second tool break detection. It doesn't need to be 4. So
I see. Yeah.
But yeah,
that's a good tip. Sorry, writing down a note here.
No, of course. And then feel free, anybody who has a Speedio, feel free to reach out because like I said, I use it all the time. It's such a peace of mind thing. Like I've been running the grills that I've talked about on the podcast before all week. And like I I use a 3/16 to rough out all the pockets in the grill, and then a 1/8, and I tool breakage both of them so that I don't blow up either one of them or my chamfer mill when it comes in at the end.
Right. Nice. And do you do that as you hand edit, or you do like a manual pass through?
Right now, it's a hand edit because I have not played around with the manual pass through enough, but I am shortly either going to figure out how to edit my post myself, or I've been talking to Next Gen Cam about buying post support and then just getting all the edits done that I need done, because they're fairly simple. And I just, now that we've got 2 Speedios, I need to get a post that works for both of them. Just get it done, get back to making parts and not screwing around with the hand editing.
Yeah. Luckily, my brother is does a lot of like programming robotics stuff. So he was up here and I coaxed him into walking through the post with me. So I got a lot of those edits there, but more usefully, I guess, was just seeing how he went about it. So I won't say I'm comfortable editing posts by any means, because I always feel like I'm going to make something crash, but a little less mystifying.
For sure. Yeah. It's Java is by no means, I just don't understand it. Like, I've done a little bit of programming here and there, and it's just, there's just slightly enough that I don't understand what I'm missing all the time. And so,
yeah, same. And then you waste like a ton of time because your syntax is a little funny or something. And and
it always seems like I edit something and then I try to use the VS Code post utility, and then it breaks that somehow, and then it's not helpful at all. And then I just get frustrated and I'm like, well, screw it. I'm just going to go back to hand editing everything.
Yep, totally. Well, that's how I'll be implementing the tool break detect for a while. You know, maybe in 6 months I'll get around to it.
Well, if I get my 0 tool offset thing worked out where I'm comfortable, I'll definitely pass it along to you, because
awesome.
It's only 2 lines, I think, that you change, and it just writes your current tool offset to a macro variable and then checks if that's 0, and if it does, then it triggers an alarm. So.
Oh, nice. Yeah, that seems like a good way of going about it. I think my tool setter has an e-stop, but I don't know if it has
then you must
time.
have the Metrol then. Does yours have the air blow?
Yeah.
Okay, then you've got a Metrol. So it does have an e-stop, but still
but full speed. Yeah.
Right, yeah. At 2,000 inches a minute, I don't know how good that's going to do you,
Yeah, it'll help, but not a lot.
Yeah, exactly.
Awesome.
Well, thank you so much for coming on the podcast. I really appreciate taking the time and getting to pick your brains about, grippers and buckles and all that stuff.
Yeah, thanks so much for having me on. It's definitely been a pleasure.
Awesome. Well, and thank you to all the Patreon supporters. No new ones this week, but I appreciate every single one of you that, help keep the podcast going and cover all the overhead and stuff. And thanks everyone for listening. We'll be back next week.